Tsunami in Puerto Rico. The forgotten danger. Tsunami, a Japanese word that means harbor wave, is used internationally to describe the series of waves caused by an impulsive disturbance that displaces a body of water. As these waves near the coastline, they can present themselves as quickly rising tide or a bore of turbulent water. Once they reach the shore, they can cause extensive flooding. A tsunami can be generated by an earthquake, a landslide, a volcanic eruption, or an impact from a large object falling into the ocean. Most tsunamis are produced as a direct or indirect consequence of a local, regional, or distant earthquake. In order for an earthquake to generate a tsunami, at least a segment of the fault where it originates must be on the ocean floor. Records show that earthquakes with a magnitude greater than 6.5 on the Richter scale can cause destructive tsunamis. But we must not forget that smaller earthquakes can cause landslides capable of producing locally destructive tsunami. Generally, the size of the tsunami is directly proportional to the magnitude of the earthquake. Fortunately, not all earthquakes produce tsunamis. During an earthquake, the movement along the fault is so fast that the response on the surface is identical to the deformation that took place on the ocean floor. Then, as the force of gravity attempts to return equilibrium to the sea level, inertia makes water rise, generating the train of waves known as tsunami. The deeper the earthquake is generated, the less efficient is the transfer of energy from the earthquake to the tsunami. This is because, for a given magnitude, a deep earthquake will produce a smaller vertical displacement than a shallow earthquake. It is this vertical displacement that creates the tsunami, so a large shallow earthquake will generate a tsunami more efficiently than a large deep earthquake. Most faults have an elongated shape. Consequently, the energy causing the tsunami will mostly propagate in a direction that is perpendicular to the fault's length. These faults can be found along subduction zones, such as those located north and south of Puerto Rico. Most tsunamigenic earthquakes have taken place in the Pacific Ocean, but there have also been reports of tsunamis in other regions, including the Atlantic Ocean and the Caribbean. November 1st, 1755, a magnitude 8.7 earthquake occurred southeast of Portugal. Most casualties, estimated between 50 and 70,000, were not associated with the earthquake itself, but were the result of a tsunami that was caused by the earthquake. This tsunami not only affected Portugal and other European countries, but also crossed the Atlantic in about 8 hours, producing 23 feet waves around Saba Island, 15 feet waves around St. Martin, and 12-foot waves around Antigua and Dominica in the Lesser Antilles. One of the most destructive earthquakes of the 20th century took place on May 22, 1960, in Chile. It left more than 2 million people homeless and caused 3,000 deaths. This earthquake generated a large-scale tsunami, which caused damage in Chile, Hawaii, Japan, the Philippines, and the west coast of the United States. In Hawaii, where a warning system was already in place, 61 people died, 282 were injured, and millions of dollars in property damage resulted. The Honshu coastline in Japan was devastated. There, 100 people died, 85 disappeared, 855 were wounded, and 1,700 homes were destroyed. Another great earthquake took place in Alaska on Good Friday, March 27, 1964 at 5:36 p.m. In some areas, the earthquake was felt for minutes. The associated tsunami caused 106 deaths in Alaska and 17 on the west coast of the United States, for a total of 123. There was also widespread damage along the shores of the Gulf of Alaska, British Columbia, Canada, and Hawaii. At 7:16 p.m. on September 1st, 1992, a magnitude 7.0 earthquake occurred in Nicaragua. Although a few people felt the earthquake, it caused a tsunami with 26-foot waves, which penetrated more than 1 mile inland. The official account reports 116 dead, 68 missing, and 3,500 homeless. Associated waves were registered throughout Ecuador, Chile, and Costa Rica. This kind of earthquake, where the size of the generated waves is not proportional to the earthquake intensity, is called a tsunamigenic earthquake. In the Caribbean, there have also been tsunamis generated by local and regional earthquakes. In Puerto Rico, both the 1867 and 1918 earthquakes generated significant tsunamis. The one associated with the 1946 earthquake in the Dominican Republic was observed along Puerto Rico's northern shoreline, especially in Arecibo. 20 days after a devastating hurricane swept the Virgin Islands, and a few days after some minor quakes had been felt in St. Thomas, on November 18, 1867, a powerful earthquake shook the Virgin Islands and eastern Puerto Rico. The epicenter was located in the Virgin Island Basin, between St. Thomas, St. Croix, and Vieques. It was a beautiful day in St. Thomas when suddenly, around 2:45 p.m., a strange noise was heard. The noise became louder and louder until the earthquake was felt, which itself lasted about a minute and a half. A few minutes later, the ocean rose about 15 to 20 feet like a straight white wall. In the bay, it swept away vessels and lifted large battleships. 10 minutes later, another wave hit, but this time it was worse and a large area was flooded. Damage was most significant in the commercial sector, where the waves entirely flooded the stores facing the bay. In St. Croix, the earthquake was felt strongly. In Frederiksted, shortly after the quake, the seawater began to recede. Then, it came back with such strength that it dragged an anchored vessel towards the beach. As the seawater retreated once again, the vessel was stranded on top of a coral reef. The quake was also felt strongly by residents of Vieques and Culebra. Immediately, waves rose up from the south of Vieques and wrapped around the island, drenching its north coast. In Naguabo, the church had to be closed as seawater entered far into town. On the coastal towns of Arroyo and Salinas, the wave was quite high, causing seawater to reach 120 feet inland. October 11th, 1918, 10:14 a.m. The island of Puerto Rico was shaken by one of the strongest earthquakes to have occurred in the region. It was felt for a little over a minute.
I was 12 years old when I felt the noise approaching. It was very loud. Then I said what came to my mind. Could this be an earthquake? I thought that by myself. Then suddenly, do you know what's like to see the horizon moving this way, that way, and again and again?
The earthquake's epicenter was located in the Mona Passage, 25 miles off the coast of Aguadilla. It was felt the strongest on the west coast, where people ran into the streets as they feared being trapped inside the buildings.
The soil was cracked everywhere. But let me tell you, now I think it was ignorance, but that was scary. Do you know what's like to see the river overflowing that fast, hitting and destroying everything in its path?
It was estimated that approximately 800 buildings were destroyed. A total of 116 people died, 40 of them as a direct consequence of the tsunami that arrived at the island immediately after the earthquake. The tsunami reached a height of 20 feet in the Aguadilla area. There, 5 minutes after the earthquake, the seawater began to withdraw as it exposed reef and parts of the seabed. Shortly afterward, the first wave hit, flooding part of the city. 32 persons were reported to have drowned.
May God never permit another earthquake like that. I only think that if something like the 1918 earthquake happened today, it would leave Puerto Rico in ruins.
At Punta Borinquen, Aguadilla, the waters began to withdraw immediately while the earthquake was still being felt, and then came back as a 20-foot wave, reaching up to 300 feet inland. At Punta Agujerada, also in Aguadilla, 8 people drowned. Hundreds of palm trees were uprooted. Here, it is calculated that the waves were up to 20 feet high. In Mayagüez, where the tsunami arrived at an estimated 20 minutes after the earthquake was felt, the lower floors of buildings located along the coast were flooded. Here, the waves reached 5 feet above sea level. Further south, the waves registered little more than 4 feet, but they were strong enough to pull out houses and drag them into the bay. In Boquerón, a town in Cabo Rojo, waves were 3 feet high. Here, the water began receding an hour after the earthquake. A small boat that was anchored 150 feet off the coastline in 4.5-foot deep water rested on the ocean floor for a few minutes when the water receded. In Isabela, along the north coast, the wave was seen by many people a half hour after the earthquake. In Arecibo, the wave was observed entering the Arecibo River. In Canóvanas, the river called Rio Grande de Loíza retreated and then surged 3 feet above its normal level. It is estimated that the wave reached the river entrance 20 minutes after the quake. Other triggering mechanisms for tsunamis are landslides, volcanic eruptions, and an impact by an object in the ocean. Tsunamis produced by these phenomena tend to be very large close to their point of origin, but as they move further away, they become smaller. Therefore, it is most likely for this kind of tsunami to affect an area closer to the point of origin. A landslide that takes place either underwater or on land, but whose debris enters a body of water can generate a tsunami as it displaces great amounts of water. There is evidence of a major landslide on the south side of the Puerto Rico Trench. It is estimated that its volume was around 220 cubic miles and that it dropped 28,000 feet into the trench. Depending on the duration of the landslide, computer models suggest that the sea level could have reached heights between 87 and 227 feet along Puerto Rico's northern coastline. There is also the risk of a tsunami caused by volcanic eruptions of either submarine or subaerial origin. Among possible submarine eruptions, the greatest threat comes from a volcano called Quicumgenny, located in the southeast region of the Caribbean, 450 miles away from Puerto Rico. This volcano has been active for many years. It has had more than 10 eruptions since 1939. Among surface eruptions, the danger is associated with volcanoes such as Zephyr Hills on Montserrat, which has recently been very active. In this case, a local tsunami can be produced either by debris avalanche reaching the ocean or part of the volcano collapsing into the ocean. In both cases, the local tsunami could exceed heights of 30 feet, affecting nearby islands, but then it would diminish quickly, not affecting Puerto Rico. Although slight, there is the possibility of a tsunami being generated by the impact of an asteroid or other large object from space on the surface of the ocean. Some theories argue that this kind of event could have caused the extinction of dinosaurs. In the open ocean, a tsunami generated by an earthquake is generally less than 3 feet high, but it can travel at a velocity of more than 450 miles per hour, the speed of a commercial jet plane. Since tsunami waves are small in deep waters and there could be miles of distance between them, a tsunami can travel unnoticed over open ocean. When it approaches the shore, where the waters are shallow, the height of the wave can increase dramatically, in extreme cases over 50 feet. At the same time, the waves slow down to less than 20 miles per hour. A tsunami is a series of waves in which the first is not necessarily the largest wave. The distance between waves may range between 6 and 300 miles, depending on the size and depth of the source area. Regardless of water depth, the whole column of water is moving below the tsunami. Unlike normal waves, where water flows in the same direction for a few seconds and is no deeper than a few feet, tsunami waves affect the entire column of water and move in the same direction for several minutes. This, combined with the distance between waves, makes water volume and energy a lot greater than in extreme surges, such as those associated with Category 5 hurricanes, the strongest in existence. Many tsunamis have waves that break differently than normal sea waves. Some present themselves as a quick rise in sea level or a sudden flood. An example of this phenomenon is the tsunami of 1918 in Mayagüez. Other tsunamis have waves that break as they approach the shore and reach land as a violent rush of water, with an abrupt front or bore full of breakwater. This usually happens when a tsunami enters channels, river mouths, bays, and harbors. This was the scenario in St. Thomas in 1867, following the powerful earthquake in the Virgin Island Basin. When the tsunami hits the coast, direct damage to property can be caused by the flooding, the forceful impact of water, as well as debris on structures and erosion of the soil. Indirect forces, which can also cause great destruction, such as fire, can be generated. The vertical height or run-up of a tsunami, as well as its penetration inland or inundation, are functions of its height in open ocean, but they are also influenced by topography and variations on the ocean floor near the impact zone. Tsunamis can travel up rivers, causing damage thousands of feet inland. This was observed in the 1918 tsunami in Puerto Rico. Tsunamis can drag deep-sea material which may later be deposited on land. The presence of this material at a particular site can be determined by trenching and drilling. Research concerning previous tsunamis using this methodology is known as the study of paleotsunamis. These kinds of studies have been done in Puerto Rico, showing that the island has been affected by tsunamis prior to the 1867, 1918, and 1947 events. Sometimes, when a tsunami strikes an island that is relatively small compared to the distance between waves, the greatest run-ups and inundations don't take place on the side of the island where the tsunami strikes, but on the opposite side. This behavior was observed in Vieques in 1867. The force of tsunami waves is enormous. A water current moving at 5 miles per hour has a force equal to 160 miles per hour winds, those associated with a Category 5 hurricane. Because of its often small height, one may see a tsunami as non-threatening, but it is capable of dragging or destroying bridges, concrete buildings, trains, automobiles, and any structure without a strong foundation, including large ships. There are many fault zones located around Puerto Rico that could generate not only significant earthquakes, but also tsunamis.
The fact that Puerto Rico is located in a zone of convergent plate boundaries puts the island in an area of high seismic activity. In the Puerto Rico region, the North American and Caribbean plates are in contact. The North American plate is subducted under the Caribbean plate. In addition, the Caribbean plate is moving northward below Puerto Rico. This is why the Puerto Rico area is very active.
North of Puerto Rico lies the Puerto Rico Trench, the deepest part of the Atlantic Ocean and highest negative gravity anomaly on Earth. It is a zone with many faults. Just south of the trench and north of Puerto Rico is the 19-degree north seismic zone, which also includes many fault systems. The Mona Canyon, where the 1918 earthquake occurred, is another zone with many faults. To the northwest, the Septentrional Fault extends from the Mona Passage into the Dominican Republic. Throughout the Mona Passage, there are many fault segments of different length. The subduction zone at the Muertos Trench, south of Puerto Rico, extends from south of the Dominican Republic and Puerto Rico. In the Virgin Islands depression between St. Croix and St. Thomas, there's a series of faults. From Fajardo to the northeast of the Virgin Islands is the Sombrero Seismic Zone, a very seismically active area. On average, between 1 and 3 quakes are recorded daily in the Puerto Rico region, although most of these are not felt. Since Spanish colonial times, more than 610 earthquakes have been reported as felt. 10 of these have caused injuries, death, and property damage. Among these, the events of 1867, 1918, and 1946 produced tsunamis. As an island, all of Puerto Rico's shores are exposed to tsunamis, but the areas of greatest risk are Aguada, Aguadilla, and Mayagüez, because of all the urban development along the coastline.
The 1918 tsunami created a gigantic wave that affected the coastline of Aguada, Aguadilla, Rincón, and Mayagüez. Because of that history, we have identified the most populated areas. Signs have been installed throughout the most populated and traveled areas, advising people to move away from the shore as soon as they feel a strong earthquake.
Here, personnel from the State Emergency Management Agency are developing a prevention system that includes drills, signs in dangerous areas, education, and an evacuation plan for schools in coastal areas.
The San Carlos Private School is located just across the street from the Aguadilla beach. It's one of the buildings most exposed to tsunami. A year ago, we began an education program for both students and teachers. They were trained in first aid, drills were performed, and signs were posted so that everyone would know what to do in case of a tsunami.
One of the best warnings of an approaching tsunami comes from nature itself. Some of the natural signs could be an earthquake so strong that one can barely remain standing, seawater receding abruptly, a sudden rise in sea level, a powerful sound coming from the open ocean. Besides these natural warnings, it is possible to establish tsunami warning systems. For the Pacific region, where tsunamis attack most frequently, the Pacific Tsunami Warning Center in Hawaii and the West Coast Alaska Tsunami Warning Center have been established. These centers use data obtained from a worldwide network of seismic stations, pressure sensors, and sea level gauges to issue watches and warnings. In Puerto Rico, the Puerto Rico Seismic Network of the Department of Geology of the University of Puerto Rico in Mayagüez is the institution responsible for the detection, analysis, location, and release of seismic information. It uses data from a series of seismic stations distributed throughout Puerto Rico, including the Mona, Desecheo, Caja de Muertos, Vieques, and Culebra Islands, as well as the Virgin Islands and the Dominican Republic.
Each of these stations sends a signal either directly or via repeaters to the Seismic Network office in Mayagüez. Once here, as we watch the data being recorded, we get an idea of each earthquake's magnitude. If we perceive that the registered amplitude of movement is high, then we can conclude it is a large event, possibly an event capable of generating a tsunami.
The Puerto Rico Seismic Network, in coordination with the State Emergency and Disaster Management Agency and the National Weather Service, have established a protocol for responding to a possible tsunami and broadcasting bulletins for watches and warnings. A tsunami warning will be released if a tsunami was or may have been generated. One or more of the following situations could apply. The seismic network registers an earthquake within the Puerto Rico region which magnitude is at least 6.5. According to the seismographs, the epicenter of an earthquake with at least a magnitude 6.5 is located on the ocean near Puerto Rico. The earthquake's intensity, according to the modified Mercalli scale, is 7 or more in any point in Puerto Rico. During an earthquake this strong, everyone will feel the event and it will be difficult to remain standing. Even while driving, one may feel the earthquake. Windows, dishes, glass objects, and furniture may break. Objects may fall from shelves. Low-quality constructions will likely be damaged. Soil may show small collapses or bumps. Pools and ponds may show moving waves. If a tsunami was generated, a tsunami watch will be issued immediately. On the contrary, if there is confirmation that no tsunami has been produced or that its effects are no longer registered, the watch or warning will be cancelled when it is safe to return to evacuated areas. It is important to remember that in 1918 and 1867, the tsunami began to hit some areas during or within minutes of the strong ground shaking. This kind of situation would leave little time to issue a warning. That's why it is important that the population knows how to identify the impending signs of a tsunami, such as an earthquake, receding water and strange noises coming from the ocean, and evacuate immediately. For landslide-generated tsunami not associated with a strong earthquake, there is no warning system whatsoever. In this case, it is critical to depend on a population capable of recognizing and acting upon significant changes in ocean behavior. In the case of a volcanic eruption with tsunamigenic potential, a watch or warning will be issued only if those in charge of monitoring notify the pertinent authorities in Puerto Rico. Given the real threat posed to Puerto Rico by such an event, it is recommended that the population educate and prepare themselves for a possible tsunami.
It is important to point out that when an earthquake or tsunami occurs, a crisis situation arises. It is important that the plan be well articulated in your home, family, or organization level. This way, people will know what to do in case of an earthquake and the possibility of a tsunami. You will know whether to go to a fifth floor, climb up on your roof, or go to another place. This has to be well planned, because upon arrival of the event, there will be crisis, problems will arise, and we must have all answers before taking action.
There are some security measures that should be taken now and during a tsunami emergency. If you live or work in a low-lying coastal zone, you must have a tsunami response plan. If you live or work in an area prone to damages by a tsunami, you should have an emergency backpack ready to carry to a shelter. Identify the places safe for shelter in case of a tsunami. Perform evacuation drills. Construction of hospitals, schools, and other critical facilities near the coast must be avoided. Always be on alert for an emergency. Not all earthquakes cause tsunamis, but some do. During an earthquake, the most important thing is to protect your life and the people around you. Seek the best place to protect yourself. If the earthquake is so strong that it makes standing difficult, use the unusual behavior of ocean waters, or a tsunami warning message is released, you must abandon the area closest to the coast immediately. In buildings with several stories, one may evacuate horizontally or vertically up in a building. The arrival of a tsunami is sometimes preceded by a noticeable increase or decrease of the sea level. This is a natural warning for a tsunami and must be taken into account immediately. Don't be deceived by small tsunami waves. They can be small in one area along the coast and be extremely large nearby. A tsunami consists of more than a single wave. Stay away from hazardous areas until the competent authorities declare an end to the watch or warning. Like hurricanes, all tsunamis are potentially destructive, even if they don't affect all coastal areas. Never approach the beach to look at a tsunami. If you are so close that you can see the waves, then it might be too late to evacuate. During a tsunami emergency, the emergency management authorities, police, and other organizations will try to save your life. Give them your utmost support.
Many people think that tsunamis will not occur, that it is science fiction. That's why just a few people have taken the necessary measures in order to prepare for this kind of event. In reality, at any moment, a massive earthquake could occur in Puerto Rico, and it will be capable of producing a tsunami with 15, 20, or 25 feet waves that could drench the coast of Puerto Rico. In light of this situation, the only solution is emergency preparedness in homes and workplaces.
As time passes without a tsunami event, we become forgetful. The destructive forces of our planet are often hard to believe. Puerto Rico is not exempt of all this. Education and prevention are our most important tools. Because anywhere, at any time, the devastating power of a tsunami can remind us of this forgotten danger.